Welcome. We want to look on binary, octal, and hexadecimal numbers. So let us look on the definition. All data in computers is stored in a series of bits. A bit is a binary digit which can be 0 or 1. The most basic form of representing computer data is to represent a piece of data as a string of ones and zeros, 1 for each bit. So this is called binary or base 2 numbers because it only contains zeros and ones. So octal notation represents data as base 8 numbers, representing 3 bits with each digit. Hexadecimal notation uses base 16 numbers, representing 4 bits with each digit. So we are going to look on these numbers one by one. So we have binary numbers or the base 2 numbers. We have the octal numbers or base 8 numbers. Then we have hexadecimal numbers. Those are the base 16 numbers. So we want to start with the binary numbers. The binary numbers. The system of numbers in everyday use is the ternary or decimal number system. It uses 10 digits, that is the numbers from 0 to 9, and is said to have a base or a radix of 10. A binary number system has a radix of 2. So we want to see the process of converting binary numbers to decimal numbers and vice versa. So first, let us look on converting binary to decimal. So let's say you are given these two numbers and you are told to convert them from binary to decimal. So let us look on the first number. So the first thing, you start counting from the right side to the left, starting from 0. So 0, right, and then now you multiply each digit times 2 to the power of these numbers. So we write, so this one now becomes, so now we write it as 7 to the base of 10. Right, so let us look on the second number. Here we also start counting, but our decimal point is the reference point. To the left, we count starting from 0. Then to the right, we start by counting from -1. And then we multiply each digit by 2 raised to the power of these numbers. And then we add the products. So we open the brackets and solve to have. So this is how it is written: 5.3125 to the base of 10. Right, so we want to move to the second part on converting decimal to binary. Here, an integer decimal number can be converted to a corresponding binary number by repeatedly dividing by 2 and noting the remainder at each stage. On the other hand, the fractional part of the decimal number can be converted to a binary number by repeatedly multiplying by 2 and noting the integer of the results at each stage. So we are going to look on some examples that will help us understand this process. So you are told to convert the following decimal numbers to binary. Here are the numbers. So let us see. So in the first number, it consists of an integer, that is 39. So we divide by 2. And here we note the remainder. So we take 19, which is 38, the remainder is 1. We take 9, which is 18, the remainder is 1. We take 4, which is 8, and the remainder is 1. So here we take 2, and the remainder is 0. Here we take 1, and the remainder is 0. So here, because 1 is less than 2, we take 0 and we take our remainder, which is 1. So this number here is the most significant bit, and this one is the least significant bit. So in other words, in writing from left to right, we start down, from down to up. So we write our answer as, so this is the most significant bit, this is the least significant bit. Right, so let us move to the second number. So this number is a fractional number. So as we said, for a fractional number, we repeatedly multiply by 2. We are not going to divide. So let us see. So we take, so this is our result. We take this integer. Then we also repeat the same with the fractional part of this result. So we write. So we also take this integer part and we multiply by 2 the fraction part. So we take this integer. So up to this point, we leave it there because there is no fraction. So in this case, this number is the most significant bit, and this one is the least significant bit. So in other words, for writing fractional part of a decimal, we write downwards. So we are going to present our answer as, right. So we turn to our third number, which is, so this number is as the integer part and the fraction part. So we are going to handle each part separately, and then we combine the final answer. So let us start with the integer part. So we said we are going to divide it by 2 while noting the remainder at each stage. So we take 29 and the remainder is 0. We take 14 and the remainder is 1. We take 7 and the remainder is 0. We take 3 and the remainder is 1. So we take 1 and the remainder is 1. So we finally take 0 and the remainder is 1. So writing our answer of the integer part upwards from the most significant bit to the least significant, we have this. So we now proceed to the fraction part where we have. So here we are going to repeatedly multiply by 2 while we note the integer of the result. So we proceed. Right. So here by writing the integers from the most significant bit, which is this one, to the least, we have this one. So by combining this answer and this one, we have this one. So right. So we now move to the other type of numbers, that is the octal numbers. So this system has a radix of 8 using 8 digits, that the numbers from 0 to 7. So we want to strict and directly go to the process of converting octal numbers to decimal numbers and vice versa. First, we want to look on converting decimal to octal. So let us see on some examples. But before that, we need to know that an integer decimal number can be converted to a corresponding octal number by repeatedly dividing by 8 and noting the remainder at each stage. This is the same case to the binary numbers, but in this case it is dividing by 8. And also the fractional part of a decimal number can be converted to an octal number by repeatedly multiplying by 8 and noting the integer of the result at each stage. So let us see an example. You need to convert this octal number to this decimal number into octal number, this to the base of 10. So here this number consists of an integer part and the fraction part. So we start first by converting the integer part as. So we take 701 and the remainder is 5. Here we take 87, the remainder is also 5. Here we take 10, the remainder is 7. Here we take 1 and the remainder is 2. So here we take 0, the remainder is 1. So this as in the integer part, we are going to write it upwards Yeah, that's from the left to the right as. So let us move to the integer part. So the answer of the fraction part is so by combining these two answers, we can write as right. So let us look at the second part, that is about converting octal to decimal. Convert the following octal number to decimal. This one. So here, the first step, we are going to number it starting from 0 to the left of the decimal point, and starting from -1 to the right the decimal point. So then we multiply each digit by 8 to the power of this number. So we write that. This becomes right. The third part is converting octal numbers to binary numbers and vice versa. So here we use this table of values given. So let us see on some of the examples. You will need to convert the following octal numbers to binary. So here we are going to use our table to convert. So we write here the value of 4 is 100. So the value of 3 is 011. So we write the value of 7 is 111. So we write. So this one becomes the binary number of this octal number. So the same case here, the value of 2 is, the value of 6 is, so this one becomes the binary number of this octal number. In the other case, you may need to convert some binary numbers to octal. For example, this one. So here, you need the value of every 3 pairs of digits. So we divide as here, because it is 1, we make the others to be zeros, because every 0 to the least, every 0 to the right of the decimal point that is not between n two digits, that 0 is not significant. So these zeros are not significant. So we complete these digits to be 100. So our octal number becomes, so 111 is 7, 011 is 3, and 100 is 4. So our octal number becomes this one. In this number, we also note every group of 3 binary digits. So we have this. So the rest of them, we fill them with zeros. So as in the case above, the zeros that are not between numbers to the right of the decimal point are significant. Also here, the zeros to the left of the decimal point that are not between the numbers are not significant. So we feel. So the value of the octal number becomes, right. So now we want to look on the third types of numbers, and those are, so the hexadecimal number system has a radix of 16 and uses 16 digits that consist of numbers 0 to 9 and letters A to F that represents numbers 10 to 15 respectively. So we want to go first to the process of converting hexadecimal numbers to the small numbers and vice versa. First we want to look on converting hexadecimal to decimal. So you are going to convert the following hexadecimal numbers to decimal. So let us see. So by numbering, you have 0 and 1. So we multiply each digit by 16 to the power of these numbers. So it becomes, so but A represents 10. So it becomes, so the other becomes 26. Second number. So by numbering this number we have 0. So we multiply each digit by 16 to the power of these numbers. But A represents 10 and E represents 14. So we write right. So we want to move to the second part, that is converting decimal to hexadecimal. So this process of conversion is achieved by repeatedly dividing by 16 and noting the remainder at each stage. So let us see some examples. You are asked to convert the following decimal number to hexadecimal. This is the number. So you are going to divide this number repeatedly by 16 while noting the remainder at each stage. So we take 27 and the remainder is 15. We take 1, the remainder is 11. So we take 0, the remainder becomes 1. But now here we said these numbers represented by letters. So this one is represented by letter F. This one is represented by letter B. So our answer, we are going to write it as, remember we are supposed to write upwards from the most significant figure to the least. Right. Third part is on converting hexadecimal to binary and vice versa. So here we are going to use this table given here. So this is the table we are going to use in converting hexadecimal to binary and vice versa. So example, yeah, you are asked to convert the following binary number to hexadecimal. So here you take the group of binary digits, and so you find their values from the table. So this one becomes the 1110 is 14, and in hexadecimal is represented by letter E, so it becomes. So next is 0111, which is 7, and it is just written as 7 in hexadecimal. So and 1010 is 10, which it is represented by A. So we write, and 1001 is 9, so it is 9. So we write it as 9, then 60. So the other case, you may need to confirm hexadecimal number to binary. So here is the number. So this one becomes, you take 1 is represented as 0001. Yeah. Then B is represented as 1011. Then F is represented as 1111. So that is the binary number of this hexadecimal number. So thank you so much for watching the video. Subscribe to the channel for more videos. Thank you.